Hi students, this is Sivakumar, 10th standard mathematics, chapter number 1. In chapter number 1, so far we have completed exercise 1.1. Now exercise 1.2. Before doing that exercise 1.2, you must be knowing the concept of relation. That means two objects are related under some specified rule or specified condition. Come on, two objects are related under some specified rule or specified condition. I'll give an example, you can easily understand. I'll give you two examples. Example number 1. I take Chennai is a capital of Tamil Nadu. So how will you write symbolically? Chennai is related to Tamil Nadu. Okay, this is called a relation. Two objects, one is Chennai, another one is Tamil Nadu. Both are related or refers relation. Even we can say that Chennai and Tamil Nadu in the form of a set of ordered pairs. Chennai and Tamil Nadu. Okay, I'll give you one more example. 2 is an even prime number, correct? You know very well, in set of all prime numbers, 2 is a only even prime number, correct? So it can be two objects, one is 2, another one is even prime number, both can be related. 2 is related with even prime number. Okay, this can be written in the set of ordered pairs 2 comma even prime number. I hope that it's very simple only. I hope that you have understood the concept of a relation. Now I read one definition. Listen. Definition of a relation. Let A and B be two non-empty sets. Yeah, you know the meaning of non-empty sets? Empty set means a set which has no element. Non-empty means a set must have at least one element. That is the meaning of non-empty. Okay, how many sets totally? 2 sets. A relation capital R from the set A to the set B is a subset of A cross B. Very important one. The relation is a subset of A cross B, satisfying some specified conditions or specified rule. If X belongs to the set A, that means X is an element of A, is related to Y that belongs to the set B through capital R or refers relation. Then we write in the form of X is related to Y. X related to Y if and only if X comma Y is an element of R. If and only if, very important one. That means if X is related to Y, X comma Y belongs to R. If X comma Y belongs to R, X is related to Y. That is the meaning of if and only if. Very important. Next one. The domain of the relation R equals set of all X belongs to the set A such that X is related to Y for some Y belongs to B. Codomain of the relation R is the set B. The range of the relation R equals y set of all y belongs to the set B such that x is related to y for some x belongs to A. Okay, look at the difference between the here x belongs to A for some y belongs to B, that is for domain. For the range, y belongs to B such that for some x belongs to A. From these definitions, we note that domain of R is a subset of A. It's a symbol for subset. Subset of A. Codomain of R is equal to B, and the range of R is subset of B. Again, domain of R is subset of A. Codomain of R, that is equal to set B, and the range of R is a subset of B. So, while working out the problem, you can understand the concept of the relation. No need to worry. Here one example. Here you are given two sets. Look at that. Let A equals 1, 3, 5, 7. You are given the set in the roster form. How many elements are there? 4 elements. And B, that is equal to 4, 8. Here we have 2 elements. Look at that. If R is a relation defined by is less than from A to B. Listen carefully. This is a rule, specified rule. Is less than from A to B. Then 1 is related to 4. Obviously, because what is given is less than, correct? 1 is less than 4. Since 1 is less than 4, 1 has to be taken from set A, 4 has to be in the set B. So 1 is less than 4. Similarly, you can write 1 is related to 8. 1 is related to 8 because what is the rule? Is less than, 1 is less than 8. Next, can go for 3 is related to 4. 3 is in the domain and 4 is in the codomain. This is the domain, this one is the codomain. You have to obey the rule also. 3 is less than 4, 1 is less than 8 and 1 is less than 4. 3 is related to 8. That means 3 is less than 8 according to this rule. And 5 is related to 8. 5 has to be in the set A and 8 must be in the set B. Finally, 7 is related to 8. 7 is related to 8. 7 is less than 8. Equivalently, you can write R, the relation R equals, you can write them in set of ordered pairs. That is, 1 is related to 4 can be written as 1, 4. Similarly, you can write 1, 8, 3, 4, 3, 8, 5, 8 and 7, 8. You can ask me, sir, why don't you write 7, 4 and 7, 5, 4? Why don't you write 5, 4 also? If you write 7, 4, 5, 4, that condition won't be satisfied. What is the condition? Is less than. Suppose I am considering 5, 4. 5 is less than 4? No. 5 is greater than 4. So you are not supposed to take 5, 4. Understand? Now, this is very important note. Listen carefully. In the above example illustration, A cross B, you know A cross B, how to write A cross B? Already have learnt in the previous exercise. 1, 4, 1, 8, 3, 4, 3, 8, 5, 4, 5, 8, 7, 4 and 7, 8. Here you are given A cross B. But we have R. Look at that R. We have 1, 4, 1, 8, 3, 4, 3, 8, 5, 8 and 7, 8. So look at that. We see that R is a subset of A cross B. Obviously, 1, 4, here it is. 1, 8, here it is. 3, 4, here it is. 3, 8, here it is. 5, 8, here it is. 7, 8, here it is. So all the elements of the relation or in A cross B. So we can say or is a subset of A cross B. Very important note. Okay, I hope that you have understood the concept of the relation. The next video I'll be teaching exercise 1.2, first problem. Thank you, children.